What a performance. Everyone should be jumping in their seats by now, right? So let's come back to participants. Next, we have Christopher Gargiulo, a returning Jonk Fuerscher contestant, and Thomas Litt, who designed a 3D model of a device that generates electricity from the flow of running water. Sounds interesting. Let's find out how they did it.
Hello, everyone. I'm Christopher Gargiulo.
And I'm Thomas Litt.
Now, our title of our project is Neptune. It is inspired by the Roman god of the ocean. This is because water is a very prominent element in our device. Now, what exactly is Neptune? Neptune is an accessible source of renewable energy. It generates electricity from the flow of water from one's residence. Simply, you would attach Neptune, our device, to a tap. Now, you may ask, why a tap? Well, taps are located everywhere, and a lot of energy is wasted as water flows from the taps. And we want to utilize this energy to fight the energy crisis we face today. Anybody can use our device, Neptune, and go closer to a more renewable society.
Now, before continuing on our project, we first need to explain what direct and alternating current are, because they are relevant to our project. So direct current is a current where the electrons only flow in one direction, whereas in alternating current, the flow of electrons reverses periodically. To better visualize this, we can imagine the electrons in alternating current starting at a point of 0 and then flowing in one direction until they reach a maximum value of, we can say, 100, and before reversing in direction and going back to 0 and continuing until they reach another maximum value of, let's say, negative 100. And once they go back to, and then they reverse directions again, go back to 0, and this would be a cycle. And in alternating current, the electrons continue this cycle indefinitely.
So here's our device. We used a 3D modeling software named SketchUp to design our device. Now, it combined the idea of the water wheel and tracks on tanks. Now, this allows us to attach as many gears as we want onto the device. Now, attached to each and every gear is a dynamo. Now, the dynamo, it converts the rotational energy of the gears into current, electricity. And we will take this example. We have on the right side, water from the tap would flow and hit the concave pedals. As the concave pedals trap water, the gravity brings the track downwards and rotates the entire track. This rotates the the gears, and then rotates the dynamos, thus generating electricity. Now, how the dynamos produce the electricity is that there are sets of copper coils that rotate around a magnet, producing alternating current. Now, the step to we need direct current to charge any device. And it is very complicated to convert the alternating current to direct current. Here's a simplified model, and we will be starting on step 4.
So in the conversion of alternating current to direct current, 3 devices are needed: a transformer, a diode bridge rectifier, and a capacitor. So the first step to converting alternating current to direct current is the use of a transformer, which is a device that converts voltage, that transfers voltage from one circuit to another. And the transformer we will be using is a step-down transformer, which will lower the voltage during this movement. This is because in alternating current, the voltage is greater than in direct current. And if we were to use an unaltered voltage to charge a device, it could potentially damage it. So once the voltage has been lowered, we use a diode bridge rectifier to convert the alternating current to direct current. A diode bridge rectifier makes use of diodes, which are a type of microchip that only allow the flow of electrons to go in one direction. And the reason why we need to change from AC to DC is because if we were to use alternating current to charge a device, it would only charge the device for half of its cycle before decharging it in the next half cycle, effectively leaving the device it is charging at 0. So once we have changed from AC to DC, we use a capacitor because we use a capacitor, which is a device that can be used to store surges in voltage. And the reason we need this is because when a conversion of currents happens, there is a surge. No, there are ripples in the waves of the voltage, which need to be smoothed out by the capacitor. So once the direct current is stabilized, we can then connect it to a USB adapter so that we can charge any device with it.
Now here are our sources. Let's save our future with Neptune.
Hello.
Hi.
How are you feeling after your presentation?
I mean, it was quite stressful at the beginning,
Yeah?
but now that it's done, more relaxed.
Yeah, I'm just happy that it's over.
Just happy that it's over.
Yeah, it was really stressful.
But did you enjoy it? Was it positive stress?
I enjoyed more the research than the presenting.
Yeah.
Fair enough. So your presentation went quite well. However, there was some feedback coming from the judges. Was there anything that you agreed upon and that you want to explore more, develop more in maybe a future project? Can you tell us a little bit more?
Yeah, I mean, one of the feedbacks that the judges gave us were to look at rather use turbines instead of a conveyor belt because they might be more efficient. And another idea that the judges gave us was look how much energy you would save with our device, like how viable is it? And this is something we would really like to look into next time that we're seriously planning to do. So
That's good to hear. So you are planning on developing this project more for the future?
oh yeah.
Together again?
Hopefully, yeah.
Hopefully.
Yes.
That's when the friendship lasts, right?
Yeah.
So what was, for you, for example, the most difficult part of the project?
Presenting.
Really, the presentation?
Yeah. Researching was fun, in my opinion. It was like interesting.
Okay. How did you pull through the presentation then? Any advice that you can give to your fellow colleagues in the future?
I don't know. I prayed that it would go well, you know. I just hoped for the best.
You hoped for the best?
Yeah, and I rehearsed a bit.
Yeah, you rehearsal. Any plans on preparing yourself for the next time?
Maybe rehearsing more, and I'd say holding the mic closer to me. I thought it was
Perfect. And then another question is, this is a very interesting topic, turning running water into electricity. What was the inspiration? Where did this idea come from?
Okay, so basically, very funny story actually. I was in physics class and I had a project idea. This is completely different. It's not this. And I was waiting for someone to finish asking their question. And I was just staring at the tap in the classroom. I was like, can't you just generate electricity from that? So that's where the idea sparked from. So then I told him immediately. And he was like, yeah, we should do this. So we looked into it, we developed this idea, and here we are now.
Wow, okay, yeah. That's an interesting origin of such a project. So were there some help, or was there like, after having this general idea, how did you improve upon it?
Well, it was more like we called like maybe once every week or 2 weeks, and we would just talk about the idea and write some notes. But outside our help, I don't think we got any at all. It was more just what we think, and then we present it in front of the jury, and they would give us our feedback, because they're the experts in everything.
Well, you two look like the best team, and you seem like you're really good friends. But we also had a lot of contestants that were here alone. What do you think are benefits in doing a project like this together?
I guess the most obvious one would be you can divide the work. And also, in my opinion, it's you feel more comfortable on stage when there's someone else with you.
Yeah.
Of course, of course. And what do you think would be the biggest learning for you two as a team?
Well, I mean, like what we can improve on?
Yes, for example.
Oh, yeah. Well, I think we can maybe spend a bit more time on the project, like plan more ahead, because let's face it, ours was a bit more rushed. than we planned on it. But next time we for sure will develop it and just plan, right?
Good. Do you agree on that?
Yeah,
Yeah,
I think
yeah.
we could have worked on. We could have spent more time on the project.
Perfect. So we will see you again as a team,
Yeah.
right?
Yeah.
Awesome. Well, thank you very much
Thank you very
for
much.
being with us, and congratulations again for your presentation.
Thank you.
And good luck with everything else.
Thank you.